I want to show you a few things today about using this picture class we're going to use for the assignment that allows us to load and manipulate images. And I want to talk about images a little bit first, briefly. So we're looking at images and application of nested loops. In other words, we talked a little bit last week, or really about a week and a half ago now, about one loop inside another, and every time the outer loop iterates, the inner loop does all the iterations, and then it resets and then goes back and does another loop and does all the inner ones and so on. And you can imagine an image has that grid pattern that we talked about as being useful for nested loops, and so we're going to look at colors along here, and then we're going to go down a row and go across. So they're a nice place to play with this idea of nested loops. So first, some of you have some familiarity with images. Maybe you've loaded an image and maybe even done some Photoshop or image manipulation kind of stuff, or at least taken pictures and seen like how big they are stored on your computer. When we look at the world, it's an example of that analog phenomenon that we talked about with sound, but computers can't represent that exactly, so we have to break it into pieces. And the way we do that is sort of two ways. One is we break the image into what are called pixels, so little picture elements is what pixel means, and they're just little squares that have a certain color. And then there's actually some quantization of the color available. In other words, the color is not a continuous stream, although there's a lot of them available, and we pick certain numbers to represent those colors. So we arrange these pixels in a grid to make an image, and we talk about the resolution of an image, and sometimes it's like the number of pixels overall, like 2 million, but more often I'd say you sort of say how wide it is and how high it is. So it's like 2,000 across by 1,000 down, and that's sort of a more useful way of talking about resolution of images. And the color, there are a lot of different ways of representing color, and certainly if you do stuff in Photoshop, you have different conversions between different color spaces. A common one in the computer is the amount of red, green, and blue. We say RGB for that. And one reason for that is that it sort of represents or matches up with the way humans see color. So in your eye, you have a bunch of specialized cells that respond to light. Some of those are called rods, and they're very high resolution and have a high range of brightness they can see in, so like at night and so on. And some are cones, and the cones see color, and there's 3 different types of cones, and one responds in the blue range, one responds in the green range, and one looks like yellow here, but sort of red is sort of where it also has a response. So in our eyes, we have things that look sort of specifically at red, green, blue, and early developers of displays thought it'd be good to trigger those cones specifically. To represent color in the computer, we basically choose the amount of red, green, and blue we want, and there are different ways of storing those numbers. One common way is to pick a number between 0 and 255, which seems sort of arbitrary, but is basically the number of integer values represented by a single byte or one storage location in the computer. So it's actually the same size as a char. So when we use a char, it is something that can have, there's 256 chars in the basic letter set, and they're represented by a single byte in the computer. And basically that gives us a lot of, it gives us a lot of range of options. Like it's enough color that we don't really see the difference between, we can't tell there's limited colors. There's like 1 billion colors available basically. So each one of those, red, green, and blue, gets one of those numbers between 0 and 255. And we talk about color channel, basically. Red is a color channel, green is a color channel, and it's just a way of thinking about images as well. One thing to note is that color in computers is an additive color space. So if we're painting like oil paints, for example, and you start mixing a bunch of colors together, you get this big gray, brown, black mess, essentially. And that's a subtractive color space. In other words, as you add colors into the mix, it subtracts the color that's available. Basically, they're absorbing more colors from the spectrum. But in computers, when you add them together, they contribute to the color. And so, for example, if you add together all of red, green, and blue, you get white here. So All red, for example, is just a red component and then 0 other components, and white is 255, 255, 255, all white. And if you have equal values in red, green, and blue, but not 255, it's some kind of gray scale, right? Like it goes from black to white through this gray range. And that's a specialized kind of picture. So if we want to work with images in Java, we need some way of getting them into the computer where we can manipulate them, kind of like we did with sound. And then we need some way to figure out at each pixel what is the color there. And so, for example, you could imagine something like we have image stored in this image variable, an image object, and we ask to get the color at a certain location. That's basically saying how far over you want to go and how far down you want to go. And this color thing comes out. And what is a color? Well, it's going to be some kind of object that somehow holds inside it these red, green, blue values. So let's look at that a little more carefully. So images often have the upper left corner as 0, 0, which is not how we think of, like, for example, like a graph space with x and y where the center is the origin. And so an increase in x moves you to the right, increase in y moves you down. So typically when you're looking at images in a computer, you're going to be sort of starting at the top of the image and moving down as we go. And again, at each location, each pixel here, we have a certain amount of red, a certain amount of green, and a certain amount of blue stored. And the computer displays that as a single color, right? It blends those 3 components together into some kind of color. Now, if we have an image, we can do things to it, and this idea of image processing is a powerful one and certainly a popular one. So, we all sort of are aware of these different filters you can have on different programs that add things onto your face, for example. And those are actually pretty sophisticated, right? They have to recognize where the face is, and then some sort of 3D model probably that does this. But basically, at its most basic, when you take a picture, often your app or phone will ask if you want to brighten it or do various little operations on it. And those are things we can do ourselves in the computer. So conceptually, if we're thinking about doing some sort of image processing, we need to look at every pixel and do something to it, right? So one way to do that is we have a nested loop. We're going to loop over all the index values for y, and each time we change a y location, we're going to loop over all the x values, which goes across. And again, that's sort of a column and row concept, and maybe those are better names for this particular thing, but x and y are common in graphs as well. So what happens when we are, we've gone down a certain number of y values, we've gone across a certain number of x values, and we're at a spot here in the image. We need to get that pixel color, so somehow extract the color, probably look at those individual red, green, and blue components, do some calculation with them, and then set the pixel color, either a new image or overwrite the old values in the original one. You probably want to, in the assignment we're going to be using, we're going to make new images for this. All right, so how do we do this? There's a lot of different ways, really, to be honest, but one nice one that I found is at Princeton for their CS1 course, they have a picture.java, kind of like standard audio.java. So it's not part of standard Java. You can't just start writing Java code without this file in the package. And it knows how to load and show an image, so we can see the results of stuff, and we can get a pixel color and set a pixel color. And that's really all we need to do, maybe along with how big the image is to do these kind of computations. So let's load these files. So I'm going to provide both an image file and this picture.java, and we need to add it to our package. So here I have a package for this lecture, and I have a Java file where I'm going to write my code in it, and then to it I'm going to take the picture.java and add it to the package, and it wants to copy it, which is good. And then I want to take my arches.java and add it to the package and copy it, and we're good. And I'm going to get picture.java up here so we can look at it. And notice it had an old package A3 on it, and I need to change this to package lecture 13. So now it knows it's in that same package. All right, let me go back to the class. Okay, so what do we want to do here? We want to let's just kind of take over this stuff. I, again, always get rid of that thing there. So picture.java defines a picture type. And we're going to make variables of that picture type. And I'm going to just call this one picture, not too exciting. And what are we going to assign to this picture? Well, I'm going to create a new picture object with a new keyword. So again, this is like when we made an array, sort of the long way. You had to say new. And I'm going to give the name of the class. And again, we haven't really done this, but this is the way most objects are built now. And then inside here, you pass any information you need to what's called construct this object. And in this particular case, it wants to know a file name location, or file name of where an image file is. All right, so again, it's sort of the same as all other variables we've made, except it's a new type, right? So it's a picture type named picture, and then we need to initialize it with some value, and I initialize it by creating a new picture object, and in this particular case, it wants to build it out of a file name. That has to be in the package here. There are other ways to get to other locations on the computer that we won't talk about right now. So if you just follow that model, you'll be in great shape. All right? And there's other ways to make a picture as well, like you can make like an empty one with a certain size and so on. I can do stuff. So from the picture object, I'm going to call this show method. And again, I don't have to provide information in here because the picture already has an image stored inside itself. And I'm basically saying, hey, picture, show me what you got, right? And when I run it, okay, phew, I was worried there. We have our nice, very oversaturated scene of Utah here. I'll have to make sure this isn't one I already did some processing on, but before I give it to you for the assignment. But that's what we're starting with here, right? This and notice I don't want to save it. I'll just quit it. So it acts, this picture class knows how to make this thing show like a little window, like a little application kind of thing. So it's kind of fun. How big is that picture? Well, we can ask it, and so I can say the width of this thing is equal to. We're going to ask the picture object how wide it is. And we're going to ask the picture object its height. And I'm going to print those things out. Ugh. Typey type. The image is width. And then I'm going to use, a lot of times people use sort of like this kind of symbol to say like by, like times, this times this. Times height. That's all. Let me close this, shrink it down a little bit so we can see more of it. Okay. Looks good, I hope. So it shows this thing. Notice this thing is now a little independent of what else is going on, right? Like I didn't have to close it for the program to keep running. But I'm going to close that, and it says it's 640 wide, X across, and 360 down. All right, so that's some useful kind of information. So I can get a color at a particular location. That color is another object type. So just like we made a picture type, now we have a color type. And basically I can ask the picture for a color location. So I'm going to make a new color type and call it color. Not very exciting. Maybe pixel would be better, pixel color or something like that. And I'm going to say, hey, picture, tell me your color. Oops. Picture.get. Gets a little, to be honest, a little non-descriptive to me. I wish it was like get color at or something like that, at location. And I'm going to give it some coordinates. So 10 pixels across and 20 pixels down. Color actually is not part of that picture class, but it's part of standard Java, and I can import it here with a quick fix. And that adds this import up here and makes it happy. And if I wanted to, I can then print out the red, green, and blue components, of that color. And I'm gonna tell you, it's a little easy to get just red, green, blue, red, green, blue. Just keep saying that I see a lot of assignments that are red, blue, green, and it looks weird and stuff like that. So the colors are red equal to color get red, and green equal to color dot get green, and blue equal to color dot get blue. So notice I'm calling a method get blue that belongs to the color object, and that's why we have the little parentheses there at the end. And hopefully we've lined up all our quotes and stuff like that. Okay, so it's saying the color is 91, 162, 244. And again, people often write that kind of like you would just write out 91, 162, 244, and people understand that you really mean probably the red component, the green component, and the blue component of a color. So when you see that notation, that's what that is. Okay, so let's try to take this image and only look at what's called the red channel. In other words, just the amount of red that's in the picture at every pixel. And we're going to set everything else to 0. So we need to loop over the pixel of the image, get the color of the pixel, set the color to be red, and then 0 for the other ones, and show the image. So to do that, let's close this thing here first. Okay. So I'm just going to do it here instead of in a method. So for int, I am going to use row, and this is going down y. So row equals 0, row less than the height, which we got from picture.height. And again, it'd be fine to say picture.height here. You don't have to make a separate variable for that. Row plus plus. And then I'm going to do a nested loop for int. Let's get the syntax at all in the same area. Column equals 0, column less than width. And in some ways, the ordering here doesn't matter. You know, if I go across rows first and then down columns, it doesn't matter in this particular case. You know, but it's the way I like it. Okay, so what should happen here? We're going to get the color. So color equals picture get at is it the column and then the row? I think that's what it was, but I need to. I think I should go back and look here. Yeah, X is the first number, the column, and then Y is the second column. So I got the color, and I'm going to grab the red color. Color dot get red. And why does it complain about this? Oh, duplicate color. Well, sorry, buddy. I'm just getting rid of that part. Okay. And now I want to set the color. So to do that, you basically want to create a new color and then set it at the location in the image, right? So I'm not changing the color I pulled out. I'm going to make a new color. New color, or I'm going to just say all red color as a little more descriptive. And it's going to be a new color object. And to build the color object, we want those 3 numbers, the red, green, and blue. And so I'm going to say I want to build it with the pre-existing red, but I'm going to put 0 in for the green and blue. In other words, it's only the red part. And then I'm going to take my picture, set at the column and row location, and I'm going to send it this all red color. So we're not assigning it, right? It'd be sort of nice if we could just say, hey, assign this into this location, but instead we're saying, use this set method and take the X and Y, and then here's the color that we're going to set it to, like that. I've added in some extra spaces, and then I want to show the picture. Let's just copy that for a second and see what happens. I'm not quite remembering exactly what it does here, but okay, so I'm going to run this. Now, the kind of weird thing is there's only one image here, and this is all red, right? And where it looks black is because there's no red, and so it's black. That's the only thing that's left. And obviously the red rock has the most redness to it, and actually white has a lot of red in it because white is all red, but also all green and all blue. And so it looks like pretty bright red in this particular thing. I tried showing the picture twice, but it only showed once. And it did change picture. I will say that when we're doing this kind of stuff, we're going to want to make a copy of the picture so we can leave the original alone. And then, so in the methods, like we're going to send it a picture, which is really a reference to the original picture. So it really is the original picture. And then we're going to make a new picture to work on, and we're going to return that new picture out of there. But that process basically is this. I'm going to make a picture copy of picture, and oops, sorry, equals a new picture. And one of the ways you can make a new picture is by giving it an old picture, and this does make a copy, right? It's not sharing a reference to the same thing. So these two pictures are independent of each other. And I can get the colors out of the original picture just fine, but now I'm going to set copy of picture to have the new value, and I'm going to show down here the copy of picture. And when I do this, I get two things showing. One, the original picture, and then two is this all red version of the picture. Man, that's some bright blue sky there. All right. So let me just review briefly what's going on here. We can create a new picture. We have this picture class in our package that defines a type of a new object that we haven't used before. And I can make a new one of those by giving it the name of a file, an image file, that's in the package as well. I can ask the picture to show itself. I can make what's called a deep copy of the picture. In other words, it's a totally distinct image by making a new picture and passing as the argument to this constructor, what's called a constructor, an old picture. So this isn't a file name, this is just an actual picture object, right? I can get the width and height out of the picture, and I can write what's going to be a pretty standard form, a nested loop to look at each pixel in the image. And then inside, also a pretty standard form, is we get the original color, we get whatever red, green, and blue information we need to do our computation. In this case, I just needed the red. We create a modified color, and we do that again by creating a new color object with 3 values, the red, green, and blue. And then I set for the new picture, the one that's the copy, I set that color. In some ways, it's not necessary to really make a full copy here because we're overwriting all those pixels with new values, but sometimes in your processing, you're only changing a few things. So you want all the original stuff, and then you're going to add to it some additional kind of stuff. You should also be careful of thinking about where you get the color from. Do you want the color from the old image, and then you're going to use it to modify the new one, or is there some sort of a cumulative effect going on where you want to get the color from this copy, and you're going to kind of keep adding changes to it till you get some final state. But it matters whether you're going and grabbing it from the original image or from the copy image, depending on what kind of changes have happened already. So again, this in order to make a new picture that's a copy, you just pass in the variable that holds the thing you want to copy. All right, so when you're doing the assignment, this is basically exactly what you're doing for each of the methods for the image. It's just what you're doing here, this calculation part, that's a little different. Or really, this part right here. Oops, this part right here. Okay, so look at that carefully, and it's not trying to be difficult. I just hope you have some fun with seeing these images change and you have control over what's going on there. All right, bye.